day 94. So today we're going to be talking about exponential properties. Okay, we've already been over this before, so let's just go ahead and jump right in. So we have a couple of different rules as well as two other rules that I added. Okay, I did this because I wanted to make sure that you guys had a thorough understanding of this. So first one is the product of powers. If I have the same base and it's multiplying times itself but with a different exponent, I just add together these exponents. So over here, this would become x to the power of 11. The quotient of powers, whenever they're dividing and they have the same exact base, I just subtract them. So over here, I end up with x to the power of 7. The power of a power is just like distribution, except it's exponent to exponent. I just multiply them together. Whenever I have a negative exponent, I don't like to write it like that. So I'll flip it and drop the sign. Flip it and drop the sign. Anything to the power of 0 besides 0 is always equal to 1. Now, two other properties which you may encounter sometime in your mathematics career are these two. This first one, if I have a negative exponent down at the bottom, I can just flip it and drop the exponent. And this bottom one, whenever they're dividing exponents, this actually translates into something very weird. You're going to take the nth root of x to the power of n. This is not something you'll see in this class, but it is something that I just want you to have in the back of your mind. So let's go ahead and take a look at a couple of the examples. So here, I'm going to go ahead and do regular number to regular number, x to x, and I'm done. But I want to go ahead and verify this with my calculator. As I've stated before, whenever we have multiple variables, there's no real way for our calculator to quantify all of those. So we have to just assign them a random value. So I'll just say that x is equal to 2. And I'm going to put in my original I'm going to put in an equal sign to test to see if this is correct. I got a true. That means I did my math correctly. Noticing this was the original problem, I just changed the x's to a 2, and this is my answer with the x changed to a 2. All right, next one. So here I have an exponent on the outside. I need to distribute it to each item and multiply it times its current exponent. So 3 to the power of 4, x to the power of 12, y to the power of 4. Now 3 to the power of 4 is 3 times 3 times 3 times 3. So 81, x to the power of 12, y to the power of 4. I'm going to go ahead and say x is 2, y is going to be 3. Let's go ahead and test this in our calculator. So I'm going to go ahead and type in the original problem. 3 multiplied times 2 to the power of 3 multiplied by 3 to the power of 4. All to the power of 4. And I need to know if that is equal to 81 times 2 to the power of 12 times 3 to the power of 4. Again, all I did was I took my x and changed it to a 2, my y changed to a 3. And it says true, so we got this answer correct. All right, let's look at the next one. So here's a more complex and convoluted one. This is a little bit more representative of what you'll see on the STAR test. So for this one, I like to go ahead and just subdivide everything. So that means numbers, followed by my x's, followed by my y's. So I'll say 8 divided by 2, that's 4. X to the power of negative 6 divided by x to the power of 2. Now, there's a lot of different ways to do this, but I'm just going to go ahead and move it to the bottom and drop the sign. I see the same thing going on over here, and I'll move them. Now I can go ahead and add them. And I'm done. So let's go ahead and verify this in my calculator. Again, we'll do it in alphabetical order where x is starting as 2. So I'm going to go ahead and put my original problem in. So I'm going to go ahead and put that fraction, 8 multiplied times 2 to the power of negative 6, multiplied times 3 to the power of 13, all divided by 2 multiplied times 2 to the power of 2 times 3 to the power of negative 2. And I need to find out if that is going to be equal to my new fraction that I reduced down, which is 4 times 3 to the power of 15, all divided by 2 to the power of 8. And look at that, it's true. So I got that one correct as well. All right, 2 more examples. So this one, again, distribution. But I see that it has a negative here, so I'm just going to go ahead and flip it just to make my life a little easier. Now I'll go ahead and distribute. All right, so now I want to verify my answer. So I'm going to go ahead and go over here. I'm going to start by putting in 7 times 2 to the power of 6, all to the power of negative 2. And I want to know, is that equal to? And I'm going to go ahead and make out my fraction here. And look at that, I got another true, so that means I did this one correctly. Let's look at one more example here, and this is going to be actually taking the square root. So just so you're familiar with this, it would be like taking it and writing this. But because of the way these rules are, and these numbers are both even, we don't have to worry about that. So I'm going to go ahead and distribute that in. I see that that's negative, so I'm going to go ahead and move it to the bottom and drop the sign. And I'm done. Let's go ahead and verify this with our calculator as well. So 2 to the power of 10 multiplied by 3 to the power of negative 12, all to the power of, I'll make a little tiny fraction. Okay. And I want to know, is that equal to this new fraction in my reduced form? 2 to the power of 5 and 3 to the power of 6. Noticing all I did was change this x to a 2, y to a 3. And I got a true, so I got this answer correct. So I want you guys to go ahead and get started on your example question, and I will see you next time.